last section of chapter 9, which is 9.4, is inequalities. They're linear inequalities in two variables and systems of linear inequalities in two variables. Linear inequalities in two variables and systems of linear inequalities in two variables. So let's start with an inequality, a linear inequality in two variables. Here's an example. 2x plus 3y less than or equal to 6. Is this a linear inequality? And if it is, how do I know it's linear? Is this a linear inequality? Is it? Yes, because the powers for x and y are 1. There is no product of variables. The product of two variables is not linear. And x and y are not in the denominator, which will mean anyway power -1 anyway. So then I know this is a linear inequality. It has two variables. What is the procedure of solving this? This is one time in which I will say that solve in no other way, in no other case I will say that. Solve means graph. I will never say that again. That solving something really means graphing that thing. But that's what it is in this particular case. So when we solve linear inequalities into variables or systems, meaning more than one condition, more than one inequality of linear inequalities into variables, and I'm asked to solve, I have to graph. If I'm asked to graph, I solve. But that's the only way. So let's think about this, and let's write the steps of solving. In step number 1, I create or establish or write the corresponding equation. And you can ask, are you changing the inequality symbol into equation, into the equal symbol? And I will say, no, I'm not doing that. But I need to, and you'll see in a moment why, I need to create the equation first. Can anyone give us the corresponding equation of this inequality? What would you say? You cannot make stuff up. You can only replace the inequality symbol with the equation symbol. You cannot do anything else. So what would you tell me to write? I refuse to believe that only Heather can answer this, right? Okay, in number 2, I have to graph the equation. What type of equation is it? We already mentioned that a couple of times already, but remind me, what type of equation is it? How many points do we need to graph a linear equation? Yes, and of course the x-intercept and the y-intercept. Yes, you can graph with the slope and the y-intercept. I don't want you to do that because it's not useful for anything else. Okay, so how do I find the x-intercept? The x-intercept. How do I find the x-intercept? Say it again. It's okay. It's okay. I didn't hear. I'm not saying it's correct or wrong. I just didn't hear it. I have a air right here is coming, and I can't hear everybody. What do you say? So, anyone? How do I find the x-intercept? Thank you. Again, I refuse to believe that only Heather knows this. So I covered it because it's 0. Can anyone give us x? Very good. Excellent. So the first ordered pair is 3, 0. How do I find the y-intercept? Thank you. Look, I cover it because it's 0. Can anyone give us y? Good. So this is 0, comma 2. In step 2, I determine the points I need, and now I'm ready to graph this equation. So 3, comma 0 and 0, comma 2. I plotted the points. Do not graph the line just yet. I have to make a decision whether this will be, don't write anything just for a second. I have to make a decision whether this will be a dashed line or a solid line. The answer is given by this symbol. If this symbol has the equal symbol, then the line will be solid. I have to write the equation somewhere near the line. That's all I graphed. So you're above, below, whatever, wherever you want, but please write close to the line 2x plus 3y equals 6. In step 3, I pick a point. Let me explain, and then we continue writing the step 3. Now, assuming that this is a plane, and assuming that I have this line in the middle of the plane somewhere, and assuming that I can extend it forever, because that's what this means, I can extend it forever, would you agree that this side is a territory, a region, but this side is another region? So I could say that this line divides the entire plane into two parts, the upper and the lower. Would you agree? Okay. So I decide to pick a point that is the easiest I can work with, and also because the line does not pass through it. So of course I'm going to pick a very easy point, which is 0, 0. I realize that I picked the point in the bottom territory. That's very important to remember. And then I plug it in. So my inequality was 2x plus 3y less than or equal to 6. So I plug in 0 and 0. What do I get when I plug in 0 and 0? What do I have on the left-hand side? Good. What do I have on the right-hand side? Now my question is this a true statement? Because if it is a true statement, then all points in this area, everywhere you want, including points on the line, will be part of the solution. But if you say that this is false, then I cannot choose this territory as being in the solution. I have to choose this territory as being a solution, the opposite one. So we have to make a decision. Is this true? Yes, it is true. So therefore, I shade in the solution. It's where the point I checked with is found. So then this is 2x plus 3y less than or equal to 6. What is? All points on the line and everything here. That is the inequality. Notice the difference. This is the equation. The region is the inequality, because that's where I find all solutions for the inequality. Now you understand that this is the only way I can present the solution. I cannot just say to you, okay, you want me to tell you the solution? Okay, then imagine that I draw the line and it's going to be the territory below the line. I can't do that. So I have to draw the equation and I have to shade in the region, and that is how we solve a linear inequality in two variables. Step 1, I have to write the equation because I have to graph the equation in step 2. In step 3, after I'm done graphing, I will pick a point. You can say, I don't want to pick 0, 0. Then you want to work harder if you don't pick 0, 0. Let's say you want to pick this point, which is 0, 10. That's fine. So you plug it in, 0 and 10. So you have 3 times 10 is 30. Is 30 less than or equal to 6? No, so you cannot shade in this Because if this point makes it into a false statement, all other points will. So you have to shade in the opposite. I personally will always pick 0, 0, but I have to remember where it's coming from. So you shade in the correct area. As long as, and you cannot, if the line passes to the origin, you cannot pick the origin to check. Okay, so this is how we solve a linear inequality into variables. Now allow me to pick a system. And these problems are on page 578. A system. What is a system? We know from chapter 4 that a system means two or more. We stopped at two equations or more, and but this is a system of inequalities, not a system of equations, but they both have to happen at the same time, right? So let's start with let's say 57, and this is x greater than or equal to 3y, and x plus 3y less than or equal to 6. Any questions? Okay, I start with the first inequality, and then I continue with the second inequality. What is the first step? Do not write anything about the second one. I'm not going to address it till I completely finish the first one. But I'm just setting some space, leaving some spaces. Yes, which is? Excellent. In step 2, I need 2 points because these are lines. So make one up when x is good. Excellent. How much is y? Write it down. 0 equals 3y and tell me why. Tell me how much is y. 0 equals 3y. What do you do to both sides to get y? Good. So how much is 0 divided by 3? Excellent. So it happens that this line passes to the origin. I need to create another point. So please, you cannot pick x and y. You cannot say 5, 10 or negative 3, 2. No. You have to pick one and determine, calculate the other. So let's say I want to pick y to be 2. Calculate x, please. The corresponding x. How much? Exactly. Very good. So 6, 2 is the ordered pair. Perfect. So I will graph the line passing through 0, 0 and passing through 6, 2. I stop for a moment to look at the inequality symbol. Is there the equal symbol? Solid line. If there is no equal symbol, dashed line. So, solid or not? Solid. Very good. So let's draw. What do I do next after I draw the equation? Write the equation somewhere. X equals 3y. I know that I have not solved the inequality yet. I only graphed the equation. Good. So now I will have to pick a point. Can I pick the origin for this case? No, because the line passes through the origin. Let's say I'm going to pick this point. What is this point? Very good. Excellent. So let's plug it in. So 6 for x, 0 for y. What do I get when I replace x by 6 and y by 0? What do I get from here? Acceptable or not? Is it a true statement? Yes, it is. Very good. So then I am going to shade in the area that has this point because it worked. So here it is. What does the region represent? X Exactly. That's it. Perfect. I repeat this exact same steps for the other one. Step number 1 for the second inequality. What is it? Good? Good. In step 2. How do I determine the x-intercept? Excellent. How much is x? So the ordered pair, please. Excellent. So now I want to determine the y-intercept. It's gone. I covered it. Very good. So what is the ordered pair? Yes, very good. So I'm ready now to graph this. Okay, it happens that 6, 0 is right here, and 0, 2 is here. I cannot draw the line before I look where and make a decision. Does it have the equal sign? Good. So it will be a solid line then. What do I do next? Right? So this is only x plus 3y equals 6, nothing else. Can I pick the origin now? Yes. For this one, I can pick the origin, and I notice that is the area below the graph. So 0, 0. Is 0 less than or equal to 6? Good. So now this is what region? So I have the green territory, and now I have the orange territory. What is the orange region? Yes. Excellent. Now remember, this is a system. What did we do with the systems of equations in chapter 4? We got a solution 2, 5. What did we do next? Mandatory. Yes. Yes. Because both conditions have to be fulfilled at the same time. So what do you think I'm going to do now? One has the green territory, the other one has the orange territory. What will I do with these two regions? Intersect. Do they overlap? Do they intersect? Yes. So the solution will be everything on this line, the vertex, everything on this line, and everything in between, where both of them, both conditions are fulfilled. So this is both at the same time. And this is the solution to the system. If I pick a point here, will it verify the first or the second? Only the second. If I pick a point here, will it verify the first? Just the first. If I pick a point here, what will verify? Nothing. But what if I pick a point here? Everywhere on the line, this point, everywhere on this line, or any point here, what will happen? Both conditions will be fulfilled at the same time. Because in here, any point you pick will verify both inequalities. Both inequalities are true. Any questions? Any questions? Any questions for me? Okay, let's look at one more and then we can start chapter 10. So let's pick one this time with fractions. We know we are not worried about that, but let's say we are. How would you address a fraction? Like we always do. Multiply both sides, sure. Okay, so let's look at 70 because I think it's more interesting. 2x plus 5y less than or equal to negative 10 and y greater than or equal to 1. And you can say, wait a minute, You just told us that these are systems of linear inequalities in two variables. True. But this one only has one. It's okay. You'll see where the territory is. So first step, what do I have to do? Yes, so then 2x plus 5y equals negative 10. When x is good, how much is y? Good. So then I have 0, negative 2. So then now when y is 0, how much is x? Perfect. So it's negative 5 comma 0. Okay. So I'm ready to graph. 0, negative 2. 0 for x, negative 2 for y. Negative 5, 0. Negative 5 for x, 0 for y. I have to make a decision whether it's a solid line or not. Solid line, I agree. What do I do next? 2x plus 5y equals negative 10. I will pick the origin because the line does not pass through the origin. And I get 0, 0, 0 less than or equal to negative 10. If this is a true statement, I will shade in above. If it's a false statement, I will shade in below. Where do I shade in? So I picked 0, 0, which is above. Does 0, 0 verify the inequality? No, it does not. 0 is not less than or equal to negative 10. Therefore, I have to pick the below. And this is 2x plus 5y less than or equal to negative 10. Are we in agreement with that? Okay. Now I see y equals 1. That's my next equation, y equals 1. This is not a point, because a point will have x as well as y. So this is not a point. How do I graph y equals 1? What type of line is it? Because it has to be a line. Vertical means position. X, position. Altitude is y. Horizontal line at 1. So here it is. Solid line or dashed? Solid indeed. And now, for such a line, horizontal or vertical, I don't need to pick a point. I just think. Let's read this. This inequality says this to me. This is a region in the plane, on the plane, with any x on the planet, but make sure that y is 1 or more. Or I can say this to you. This line now divides the entire plane into a piece above and a piece below. But I am specifically told, pick any x you want. There is no restriction on x, but y is restricted. It can be 1 or more. So what do I shade in, above or below? Where is 1 or more? Correct. Perfect. So that's the, what do I do now with the green and blue territories? What do I do with the green and the blue territories? Like we did with the orange and green a minute ago. Find the intersection. And I see that I can continue this for you to see it even better. Do the green and the blue overlap? On this line, this vertex, this line, and everything in between. This is both. That's the only territory that solves both inequalities at the same time. Any questions for me? Any questions? I had all my handouts. I had a ton left. Ah, here they are. Okay. Any questions about chapter 9? You will not remember between now and Thursday because this is not something that we normally think in. I do because that's my job and that's what I know. It's probably the only thing I do. That's what I do. But you may forget all this if you don't practice. Okay, so let's go to this handout. I have to say that this chapter is not a very sophisticated chapter, or if you want, it's not, it has a lot of applications. It has a lot of applications, but at least the first part is rules, and more rules, and more rules about radicals. Before we understand these rules and are able to apply them, we will not be able to get to applications. So as you see, a lot of things that we have to identify, a lot of examples. The idea is that we complete this handout and then we go back to the book and do more problems from each section. Okay. So rational exponents, radicals, and this is later. I don't want to even talk about it now. But rational exponents and radicals are together in the same chapter because they mean the same. So when I see a radical, it can be changed into a rational exponent or a rational exponent, an expression with rational exponents, which means an exponent that is a fraction. And when I see an expression with an exponent that is a fraction, then I know it can be changed into radicals. That is the first idea. And that idea is right here in the very first line. This is a radical notation. So first we have to explain what this is, because it looks very weird, right? Difficult to understand. Not at all. So that's my first step. First of all, how we read it. I don't even know how to read it yet. I didn't explain that. Here's how we read it. The nth root of a raised to the mth power. The nth root of a to the mth power. Now let's take it piece by piece. So the nth root of a raised to the mth power. So what does n mean? It's the index of the radical. And the index can be 2, 3, 4, and so on and so forth. Now, if the index is 2, we don't write it. We don't write that. How much is the square root of 4? So this is the square root. How much is the square root of 4? 2. Why? Since 2 raised to this index, raised to this number that we don't write for the square root is 4. That's why. The index, as I said, can be 3. If the index is 3, this is called the cube root. Can anyone tell us what I should write here, since that number raised to the third power is 8? 2 indeed. So the cube root of 8 is 2, since 2 to the third is 8. Okay, one more. And of course, you got the picture, right? It can be 2, it can be 3, it can be 4. Let's look at 4 also. Let's say of 16, and please tell me what this will be. Yes, 2, since 2 raised to which power? 4th power is 16. Okay, I'm coming back to this notation. This is what it's called, the radical notation. It's on the handout. The radical notation is the nth root of a to the mth power. Okay, so now this symbol is the radical symbol. That's the radical symbol. And the quantity under the square root or the cube root or the nth root, this quantity has a special name, has a name. We have to remember this name. It's called radicand. So any quantity that is completely under a radical, it's called radicand. The whole thing. Now, if I have this situation, let's say, the square root of x plus 1 minus 3, negative 3 does not belong to the radicand. The radicand is only this quantity that is under a root. The index is 2. Okay, so I mentioned here that a rational exponent, an expression with a rational exponent, is a radical. And a radical is a rational exponent, an expression with rational exponent. How can I express that? Here's how we express it. The nth root of a to the nth power equals the base. Of course, this is the base of the exponential notation, raised to a fraction. The index is always in the denominator. The power is always in the numerator. So m at the top, n at the bottom. This is m and this is n. The nth root of a to the mth power can be replaced by a raised to m over n. So if you'd like to fill it in your handout, it's a raised to m over n. So now let's read this. In other words, maybe I should have put a comma in there, comma. In other words, any radical expression can be replaced by an exponential expression with what? So let's look here. Any radical expression can be replaced by an exponential expression with what? With a fractional. What is this? If this is the base, what is this? Exponent. So please fill it in. In other words, comma, any radical expression can be replaced by an exponential expression with a fractional exponent. One more time. In other words, any radical expression can be replaced by an exponential expression with a rational exponent. So in other words, here's what I'm saying. A squared is not a radical. Not a radical. But what about a to 2/3? Is this a radical? Which index? Excellent. And the base is a. Which power does a have? So the denominator is always the index, the power is the power, the numerator is the power. Okay. In the radical notation, the index is denoted by lowercase n. That's the index, lowercase n. Possible natural numbers for the index are, what do I put in there? What is the smallest possible? 2, 3, and so on and so forth, dot, dot, dot. The quantity or expression under the radical symbol is named radicand. So please put it in. Perfect. So now we have some examples. So the square root of 9 is why? Because 3 to the power of equals 9. The cube root of negative 8. Very good, because since negative 2 raised to the equals the fourth root. The fourth of 16 is, since 2 raised to the equals, good. The fifth root of 32. Since 2 raised to the fifth power is, that's it. There are blah, 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 and blah, blah, blah indices. Look at these and say the indices can be this or that. They're all positive. Remember the possibilities for the index are 2, 3, 4, 5, 6. So what categories we have in those numbers? 2, 3, 4, 5, 6. 2 categories. They can be, it's very important for radicals. They can be, they're all positive. We start with 2. Thank you. Absolutely. It's a huge difference between the two. Huge difference. And you will see why. Do you remember we graphed one of the radicals with an even index? It was on on Unit 1 test. What type of graph was that? What type of index was it? It was the square root, right? And what was the problem with the square root? It's what? It's domain. It cannot be, the square root doesn't exist on any number. You cannot take the square root from negative 4. So the even indices have problems. The odd indices are very friendly. Look, as an odd index, the cube root, I was able to take it from a negative number. I was able to take it from a positive number and also from 0. But for a square root, I cannot, or the fourth root, I cannot take it or I cannot apply it to a negative number. So that's why this categories, the 2 categories are very important because they are totally different. Okay, I still have 3 minutes. Allow me to finish this. Change the radical expression into an exponential expression with rational exponents. Simplify completely. So tell me how to write the square root of 2 to the 10th power. 2 raised to which power? 10 over 2. You can write it as 10 over 2, and the answer is 2 raised to the... Very good. This is it. We simplified it. The next one. Yes, it's the cube root, so I can write negative 3. I'm okay with that. Raised to 9 over 3, which is... Yes. So the answer will be times another 3. Negative 3 times negative 3 is positive 9. Times another negative 3, I get negative, oops, negative 27. Perfect. Okay, what about the fourth root of negative 3 to the fourth? Remember what I said, even indices have difficulties or problems. So I have to simplify inside the fourth root first, which I did not have to do here because I know that if I have a negative radicand, the answer will be negative. But if I have a negative radicand with an even index, I have to simplify it first inside. I cannot just copy negative 3. So this will be the same thing with the fourth root of it's 9 times 9, right? I'll have four threes. How much? Good. And how much is the fourth root of 81? There are 4 threes in there. Right, you can go back now and change it into 3 to the fourth, copy the base, what happens to 4 and 4? Right, it's 4 over 4, which is 1. Good. Radicals with indices cannot be applied to. So that's our first note here. Radicals with what type of indices? Cannot be applied to what type of numbers? Very good. Very good. Excellent. Please keep that in mind. The square root of negative 4 cannot be. Forgive me, I think I held you 1 minute over. I apologize.